Okay, y'all, it's Miss Scoggin again, continuing on with our day 4 notes. We are going to just keep trucking along, and we last class talked about average atomic mass, and then we talked about how the units are AMU, and we went over on how to calculate all of that fun stuff. But today, continuing on today, the next thing we are going to talk about is molar mass and how to calculate molar mass. And molar mass is very important, and it's really crucial that you guys are able to grasp how to calculate molar mass and when it is used, because we're just going to be using molar mass the rest of this year, especially when we get into stoichiometry and at any point in time where we are needing to calculate how many moles are in a given in a given substance, or any time we need to calculate if we're given grams and we need to go to moles. This is when molar mass is going to be crucial. Okay, so our molar mass, all right, is used to calculate the mass of 1 mole, okay, 1 mole of a compound or substance. Now, you're probably thinking, Miss Goggin, what the actual heck is a mole? Okay, so what that basically means whenever we're talking about a mole of something is you can't see a mole, okay? But you are able to calculate it because our units for molar mass, and you can kind of see our units for that, is going to be grams per mole. But what I can tell you is you can see mass, right? And on our periodic table, we have our average atomic masses, okay, for each element. So boron, you can see, is 10.81, and these are all grams, okay? And then carbon, you can see it's 12.01. So whenever we are calculating molar mass, whenever you need to find those mass values, you always will look at your periodic table. So when in doubt, a lot of times, and you guys will, you have these in front of you, these periodic tables that have all of these handy dandy, notes and everything. But the main thing is this periodic table is like liquid gold, okay? You don't want to lose it, and because you will need it to help you calculate everything. So there's a couple ways that people calculate molar mass, but at the end of the day, we get the same thing. I'm going to show you guys how I do it and how I was taught, and just kind of feel like it works the best, and you can kind of organize and not get things messed up. We have a couple of examples here. So this first example, it shows us, it's asking us to calculate the molar mass of ethane. So ethane right here is a compound, okay, because it's not just one element. You have carbon, you have 2 carbon, and then you have 6 hydrogen. Okay, so it's wanting you to calculate the molar mass of this whole thing, okay? So when you do that, this example right here shows that you can list them out like this, but how I do it basically is I like to do arrows. So I start with in the back, and I bring my arrow down, okay, and I have hydrogen. So I would put 6 here because it tells me that I have 6 hydrogen, okay? I will multiply that, and if if this was not already here to show me, I would go to my periodic table, and I would go to hydrogen, and I would say, okay, that mass for it is 1.01. So I would do 1.01 equals, okay? And then I'm going to switch colors, just because when I switch colors, it helps me keep things organized, okay? So I'm going to then take my next arrow and bring it down, and it tells me that I have 2 carbon. So I'm going to do 2 times our mass of carbon, which again, periodic table says 12.01, equals, okay? So I'm going to put this in my 6 times 1.01. It gives me 6.06. And then over here, it gives me 24.02, okay? So I have those values, and I just noticed that I used green and red for Christmas, even though we still have Thanksgiving. But anyways, I'm going to now add these, okay? So I will add these values, okay? So I will do my 6.06 plus my 24.02, and you can see right here it says 30.08, and we always do, 2 decimals after, and we have grams per mole, okay, because that is our units, grams per mole, because again, like I mentioned, molar mass is used to calculate the mass of 1 mole, okay, 1 mole of a compound. This is our this is our compound. Holy cow. Just choked. I'm fine. It's fine. Okay, moving on. On example 2, I'm not going to go through that one with you, but I will say there was a little bit of an error. It had a Ca, calcium, nitrogen, and then it had an H for hydrogen, but it really should have been oxygen, and it has the correct mass for oxygen, but just so you know. But okay, here we go. I am now going to do practice 1 with you. So it's wanting us to calculate the molar mass of glucose, okay? Glucose, C6H12O6. So I'm going to take my first, I'm going to start from the right, okay? And I'm going to do my arrow. It tells me that I have 6 oxygen. I will multiply 6 by my mass of oxygen, which is 16, and also, go to your periodic table to find that, okay? I'm going to just grab another color, and I will do my arrow down, and I have 12 hydrogen times the molar mass, which is 1.01, equals, next color, I have 6 carbon. My mass of carbon is 12.01 equals, okay? So I'm going to now multiply to get my values. So I'll start at the top. 6 times 16 gives me 96. 12 times 1.01, that gives me 12.12. And then I have 6 times 12.01, that gives me 72.06. Okay, so I'm going to add all of these up to get my molar mass, okay, and that gives me 180.18 grams per mole, okay? Very important that you have units. Okay, so that is how I show my work to do molar mass. You can do it this way if you'd like, completely up to you, but you do have to show your work, whether it be how I do it, how Ms. DeLong does it, how Coach English does it. There needs to be some type of work shown that what element you have, how many you have, the mass of it, and then the total, and then adding them all up to get your molar mass. Okay, let's keep trucking along with practice number 2. I'm actually going to skip down to practice number 3 because, so y'all can do practice number 2 on your own. I'm going to skip down to practice number 3 because I really want to show you how you need to deal with parentheses. Okay, so this SO4 right here, that is one of our polyatomic ions. And we'll get comfortable and familiar with those soon. But this SO4, okay, that is sulfate. So what this basically means is you have 2 aluminum, okay? This 3 right here is telling you that basically whatever you have in that parentheses, you'll have to multiply it by. Just like in math, whenever you have parentheses, you got to keep that in mind. So again, I'm going to start from the back and work my way. And the reason I do that is because of parentheses. Because I sometimes feel like if you work from left to right, when you got to the sulfur, you might not have realized that, oh, I have a 3 over here, and that 3 applies to the sulfur also. So I'm going to take my arrow, I'm going to move it, okay? And right here, I have oxygen. Attached to oxygen is a 4. But I also have this 3 outside telling me that I have 3 times that. So all you're going to do, okay, is I'm going to take my 4 times 3, okay, which everybody knows 4 times 3 is 12. So I'm going to take, showing me I have 12 oxygen. So I'll do 12 times my mass of oxygen, which is 16, equals, okay? Just go ahead and plug that in. It's 192. Then I will move on to my next one, okay, sulfur. Sulfur is just showing that I have 1 sulfur right now, but then it's in the parentheses and I have a 3 out here. So that 3 also applies to that sulfur. So I have 3 sulfur times the mass of sulfur, which is 32.06, okay, equals. So I will plug that in my calculator and I get 96.18. And then my last one, I have aluminum. Now, aluminum is not, there's no parentheses around aluminum. Okay, so this 3 does not apply to aluminum, but there is a 2 attached to aluminum, so I have 2 of those. So I'm going to do 2 times my mass of aluminum, which is 26.98. Multiply that by 2, and I get 53.96. Okay, so now I'm going to add all 3 of these together. Okay, and I get 342.14 grams per mole. Okay, I would box that in, and that is my answer. Okay, so if at any point there's a question and it's asking and it says, calculate the molar mass of aluminum sulfate. This is your molar mass of this entire compound. Another huge thing that is super important for you to be able to calculate molar mass is whenever we get into being able to calculate the percent composition of just certain elements, you would need to be able to calculate the molar mass and get that, because if you don't get the correct answer for that, then everything else is going to be done incorrectly. So I did these 2 examples with you. I would like you to now practice 2 and 4. Make sure you keep in mind the parentheses that are given and how many you have of each.